All right. Good evening, everyone. This side Ashutosh, and hello and welcome to Cloud Native Community Group, Dehradun. And we have. I hope everybody can hear me. Okay, if you can hear me, just write in the chat if any problem. All right. So thank you so much for joining. So we are extremely excited to have you all here. And either like most of you are joining from your home since it's a virtual event, and I would like to thank you, and so today we'll be focusing into the cloud native journey and DevOps, Kubernetes, and some of the open source thing. Although with some of the talks, might appear to be very technical, but we try to keep it on the cloud native side as easiest to grab as possible. So bear with us, and I would request you all to have your questions handy whenever you have. Once the session is ending, then you can always ask them with our respective speakers, and we do have a Q&A at the end. And I would wish everyone good luck, and you should make this enriching, interactive. And we are waiting for our speaker to join in. Then we will start the first talk. So that is the Abhinav from Code Cloud, and I heard like you might be knowing the Code Cloud platform. So they are a big ed tech company in this, and they are teaching the cloud native things to you. So we shall wait for other people also to join, and then we will start. So I would request everyone to share this and ask people to join in. And yeah, All right, so I think Abhinav is with us, and he's our first speaker, and he will be, guiding you through this, uh, and so basically how you can make the production ready clusters from setup to scale in minutes. And he is the uh, site reliability engineer at Code Cloud, and it's very great for to have him so that he can give us the live exposure of cloud native environment. And Code Cloud is such a big thing in this cloud native space. So I welcome you, Abhinav, and if you are here, you can start with the session, and if you want to take like 1 or 2 minutes, that's okay. Can you hear me? Over to you, Abhinav, if you can hear me.
Hello, am I audible? Guys, ping me if you can hear me out. Okay, awesome. Okay, yeah. So I think visuals are also there. Okay, right. Just give me a second. Giving a small, doing a small setup.
Yeah, hi, Abhinav.
I Yeah.
There's some issue with my because like at my native in mountain, so there is some issue also. So
Okay.
sometimes my voice is being a weekend, but I really appreciate that you took some time from your schedule.
No issues at all.
And here it is about all the freshers in the Dehradun, and we have lot of almost like 60-70% who are just being graduated and who are new to the cloud native space. So we have
Okay.
to keep this thing in mind and make it more interesting and engaging, because so
Hmm.
that motivate them. And you know better than me how to do that.
Yeah.
And
Yeah.
they are very gracious, they just want to learn. And yeah, most of them would be having question of how to crack a first time job, and all those that actually naturally happens when we are fresher. You also know that. But
Yeah.
again, that's our job, how we can guide them better. And
Okay.
I hope your experience will help them a lot.
Definitely.
All
I will
right.
try my best, though.
Yeah,
Yeah.
yeah, over to you then. So we will be waiting for a couple of like 2 or more minutes. You can take your time, and
Yeah.
then the more folks are joining in.
Hmm.
So then, if I'm not available, like my mic goes off, then Mohit is also here. He's the
Okay.
co-organizer, so he can
Okay.
assist. All right, thanks.
Right.
All right, guys. So please ask your friends also to join, and we are going to have a good interactive session with Abhinav. And please take the best out of this, and let more and more people join. Spread this like a wildfire, because we often in the, like the controversies get what you call spread like this, but you should spread this also.
Yeah.
All right, guys.
Okay. Okay, guys, we will wait for 2 more minutes, and at around 3:15 we will start. Right. Okay. So I think we can start now, guys. All right. Um, Let me start sharing my screen. So you guys are hearing me properly, right? So if we have to wait for some more time, just do let me know, or else we can start with the session. Okay, so I will take that as a yes, and we can start. So it's my first event with the CNCG Dehradun, and I myself has lived into Dehradun for a few months last year. So I do had a a great connection with the Dehradun. I really love the city. Okay, so yeah, with that, let's start. Okay, I was just checking my presentations because I have prepared this just the last night. Okay, so I don't know what what stuff I've added here. Okay, Mohit, if you are there, I am starting right now. Okay, can you just respond
Yeah,
me?
yeah, yeah. You can start. You can start. And sorry to give you very less time.
Oh, okay, no issues. I will try to wrap it up as soon as possible. Right.
No, no, no. That's okay. You can take your time. We have time. Yeah, even if
Okay.
you want some more, like we can
Hmm.
give,
Okay.
then you
All
can
right.
start.
No.
I was saying sorry for to give you very less time, to prepare. That's what I was saying.
That's not an issue. Like no issues at all.
And
So
next
as
time we will be
hmm,
making it like a offline one because that's more
hmm,
personalization thing. But this
yeah,
time due to exams and all, because students are also having their schedule tight. So next time most
definitely,
likely we will call you guys here. So
definitely, yeah, no issues.
yeah.
Okay. Okay, so as Ashutosh told me that most of the students here, you are students or the recent grads or the professionals who are interested to be into the DevOps, SRE, and cloud spaces. So first of all, I thought to create, something very extensive and the complex architectures and explaining those bits. But what I felt is, when you sit into the interviews, they won't ask you to create the clusters. They won't ask you to, just go and do something like that, set up a service mesh or something like that. I'm not throwing the hard jargons or at you. So the questions will be around the foundation of Kubernetes. What is Kubernetes, how Kubernetes works, its components. So keeping that in mind, I've created this session as much as simple as I can. And so you know what the prerequisite. It's nothing. You just have to heard this word Kubernetes. It's enough for me, and from that I can take that up from there. Okay, so the session will be about creating the production ready clusters. And in this session we are going to see how to set up a cluster, how to deploy an application. I was working, not entirely me, the company was working on small applications, because if you have heard code cloud in past, so we offer different kinds of cloud native and those things, courses and all on those, and even the environments as well, where you can test and try out your knowledge. So we create those applications. And the best part is, we get thousands of requests in a minute. So we have to provision thousands of clusters within a single minute. So how are we able to do that? So a bit light, I will shed that light on that part as well. Not able to explain the entire architecture because it's too vast and it's bit complex for me to make it understand to you all. But yes, we will see how far we can go in this session. We'll try to do our best. Okay, so I think you guys get the idea of what I'm talking about, what I will be going to explain you guys, right? The people who still didn't get the idea of what is going to cover, I have written an agenda of this today's session. So first we'll see what is Kubernetes, a very basic one, a very basic question, and the first question thrown at you by the interviewers is what is Kubernetes, right? Second, we will see the components of the Kubernetes, how these components interact with each other, right? Once you understand the Kubernetes, third, we'll see the cloud managed and on-prem. This will be a go-through slide. You don't have to, sit on this slide much. We'll cover this very rapidly. Then we will see the K8s versus K3s. So the one who have heard of K3s yet, good. If you have not, I will explain you what is K3s and what is Kubernetes, K8s, and we'll see the differences. Then we'll jump into a very small demo. It will not take much time into the demo part. And then still, if someone have something in mind, we can have a Q&A around that. Okay. All right. With that said, a small introduction about myself. I'm Abhinav Sharma. I am an SRE, Site Reliability Engineer at Code Cloud. So SRE, in a very layman's term, it's all the what DevOps do, the SRE do. But with that, the SLA, the optimization, the security, and on those aspects of the infrastructures comes under the SRE responsibilities. Okay, so that those things I manage at Code Cloud. Apart from that, I'm also a Microsoft MVP, Most Valuable Professional. It's an open source awards given to the professionals who showcase their skills. So I have MVP awards in Windows and Azure and AI services, etc. I'm also a GitHub Campus expert, and I'm a Google Summer of I was a Google Summer of Code mentor. This year, I might not be getting that much time to indulge, but yes, I was at OpenSUSE. I have done 21x multi-cloud certifications. These certifications include GCP's professional architect, and then the Azure certifications, then OCI, Oracle, and Alibaba. And recently, I've done CKA and CKADs because we revolve around in Code Cloud. We revolve around CKA, CKADs, KCNA, KCS. These Linux Foundation certifications for Kubernetes. So yeah, this was about me. Why I have told you about me, so that you can validate that yes, the person in front of you have a bit of knowledge and he can share it with you. Okay. All right. So yeah, let's directly jump into the topic. So question is Kubernetes. So whenever you hear a new jargon, the word pops up into your mind is what, why, and how. What is Kubernetes? Why do we need Kubernetes? And third, how it works, right? So I'll try to answer all three questions, and try to answer it, simplify it as much as I can, to make you understand the entire concept of Kubernetes. Okay. Yeah. So, with that said, first of all, Kubernetes is not the only alternative available in the market. It is not a domain, right? As you write DevOps, DevOps is a domain. You pursue your career as a DevOps. So Kubernetes is just a tool. It's not the entire industry. Okay, so do not confuse it with that. It has alternatives in the market available. Of course, there's Docker Swarm, there's Apache Mesos, there is Red Hat OpenShift available, which is again working on top of Kubernetes. But yes, there are alternatives, but Kubernetes had become a industry de facto standard. Almost every company which I heard around and working on microservices, they use Kubernetes in one or other way. Docker Swarm was widely adopted because Docker is a stack. I think you guys might know about Docker. Who don't know about Docker, consider it just a container tool. It helps you to create the container. It helps you to create the small applications in and pack them in a container, right? That's a layman language of Docker. But yes, its Swarm is used to manage those Docker containers. Yeah, so that was about Docker Swarm. Now companies are migrating from Docker Swarm to Kubernetes. Most of the companies, I'm not saying that they are migrated, but yes, due to the limitations, the there are so many things. There is a resource limits and there's PSPs and so many things. We'll not go that deep, but yes, these are the alternatives. Kubernetes we are going to discuss in this session, and this is used in most of the even I think the sessions which are followed by me, they might going to explain you one or other aspect of Kubernetes. So that's why it's important to understand this first. Okay, so this is a very ugly diagram created by me, so pardon the paintings, but yes, this would be a good way to explain you how this complete thing is working. Okay, so imagine that you gone in a restaurant, right? In that you order something, you order a food, right? That order comes to the hotel's kitchen, the restaurant's kitchen, and there is a master chef. his or her duty will be to assign the recipes, assign the orders to their worker chefs, right? There you can see the three worker chefs are there. So based on their skills, how much occupied they are, these recipes are assigned to them. For example, first one is preparing the appetizer, second one is the main course, third one is the dessert, right? So they prepare those recipes then served to you, right? So now changing the nomenclature, this master chef is the master node which gets the request. These worker chefs are the worker nodes which fulfill those requests. These recipes which you ordered are your applications which you want them to run. And now you cannot ask anyone to just pour everything into your mouth, right? You just want a utensil. So that utensil is known as the pods on which your applications are running. Okay, so this entire flow where master is getting the request, distributing that request to the workers, and then workers are preparing and then serving to the customers, this entire flow is known as Kubernetes. Kubernetes is just an orchestration tool. Orchestration means it manages the containers, it manages and it deploys, and it everything related to the container management is handled by the Kubernetes, right? So this is Kubernetes, and I think with this chef example you are also able to understand it very clearly, right? So I just asked GPT how to explain Kubernetes. It's a way back, not for this session, guys. It's a way back. I asked how I can explain Kubernetes to a 5-year-old guy, or my taxi driver, something like that. So this was the example came up, and I really like this example to explain the Kubernetes. So I thought to put that. Okay. Okay. So yeah, if you don't like that way of understanding the stuff, this is what is published on the official Kubernetes website. There, this is the architecture of Kubernetes, although it's not that complex, but at the first sight you might feel it, you might not able to understand it properly. Okay, so there is a cluster. Within that cluster you have a node, master node. Master node is also known as control plane. You can say the control plane components or the major components are run on the master node, and there are the worker nodes on which the actual application is running. So again, I am this diagram is bit clumsy and you might not be able to understand it properly. I have simplified it in my way. Okay, so pardon my drawings again. I'm very bad at creating these diagrams, but yeah, um, there is a master node, there is a single master node, and there are three worker nodes. Okay, master node, and trust me guys, whenever you sit in any interview, why I have picked this complete topic before going directly into the demo, because whenever you sit in the interviews, there are questions which are related to these components. Each and every component is very important, right? Whether it's a certification or whether it's an interview, so you must know. Either one line is okay, if you know a one liner it's okay, but you should understand what are these components. If you want, you can take a screenshot of this complete slide, because whenever you are going to prepare up for your interviews and any certifications, you might know how each and every component is working together with each other to make a single request served. Okay. So let's understand it like that with the master node. So it's a main node which have the components mentioned here: API server, key value store, controller manager, and the scheduler. So first is API server. API server is responsible for authentication and authorization. Okay. So whenever you click any URL and that request goes to your Kubernetes cluster, it first goes to your master node. Now here it do the authentication and authorization, which means it authenticates that the request which is coming is authentic, right? For example, there is a person called A, and A requested that I want to create a pod. Okay, so creation of pod is authentic, because yes, you can create a pod in Kubernetes cluster, right? But authorization means whether A has permissions to create those pod or not. That is called authorization. Once API server authenticates it, right, this step is over. It sends the request to the key value store. So key value store in Kubernetes, you can store, it's a very simple store. If you have heard of Python, C, C++, so wahan pe you have heard of key value store, key and a value pair. So every entry done in the Kubernetes is in the form of key and value pair. We use HCD. I don't know if you have heard of, but HCD is the key value store database where you store each and every entry. Like A created the pod, so that direct entry goes into the HCD first. HCD, after doing the entry, sends it to scheduler. Scheduler job is to schedule those pods or schedule those requests on these worker nodes. Okay, sorry. So these worker nodes then serves those requests. Okay, for example, pod creation request from scheduler goes to any one of the pod, and then any one of the node, and this node is responsible for creating it. Finally, the controller manager. So controller manager is the one which controls the state. It's a state management component, right? So what happens before the Kubernetes is, whenever you create an application and run it as a Docker container, right, we don't know whenever or wherever our code is crashing. Okay, because I know how much perfect you can write your code. It happens to me every day. How much perfect you write your code, it will crash. It will crash anyway, anywhere, right? You can't predict whether or not it will crash. So before Kubernetes, it was hard to navigate that what is crashing, what is causing the issue, right? So to tackle that, controller manager component is introduced, which actually whenever your pod is crashed, it recreates it. Whenever you want to delete it, it sends the request. Whenever you want to increase it, replicas mean you want to increase its copy to serve the more request. So those all stuff is being maintained by controller manager. Okay, so these are the major components of the master node, and you must mug up it. If you don't able to understand it, just mug this up from anywhere, and you can ask me as well. I can try to write this down, whatever I'm saying. But yes, it's an important component. Then the request, what happens when a request goes to your worker node? So when a request is coming to the worker node, there is a kubelet component, and this kubelet is a service which is running on every node, and this is responsible, it's like an agent. Agent का काम क्या होता है? Bond 007, whatever task you given to it, it will complete it. Okay, so this kubelet is responsible for creating those containers, those pods, those services, or whatever you object you want, it will create that, right? So that is kubelet. There is one more component which I forgot to mention here, is kube proxy. So kube proxy is, by the name suggests it, you can say it is a network management component. It will handle all the networking. Okay, for example, here pod A wants to communicate with pod B, so there is a network pipeline between them that is being managed by the kube proxy, and it is installed on every node, even the master node as well. So I think I'm not that fast. If I'm fast, you can just tell me. But um, this is the overall diagram or the overall working of your Kubernetes cluster, right? Okay, let's see what I have next. Okay, so this is about cloud managed clusters and the on-premises clusters. So till now you have get the idea of what a master node is, what a worker node is. Now there are two things. When you allow cloud providers to manage your master node, right, you are only concerned about deploying your application, right? You are not concerned ki kya infrastructure hai, which version of Kubernetes is running, and you just want your application to be running fine, right? In that case, you opt for the cloud managed solutions, right? If you have heard of Google's GKE, Google Kubernetes Engine, there is Azure AKS, Azure Kubernetes Service, and I think AWS have EKS, Elastic Kubernetes Service, right? So every cloud provider has its own managed Kubernetes services. Okay, what helps in this managed thing is you are not concerned about master nodes. So in the previous slide you can see there are so many components, so you can only imagine that how much hectic it has become when you manage each and every component manually by yourself, right? So when you want to save yourself from this complete overhead, you go for this cloud managed option. In this, you just mention your configuration and it will spin up the master nodes, the worker nodes, and complete setup for you. You don't have to do a single thing. Okay, but there is a charge overhead because they are managing this stuff, so they will ask you to pay more pay more for it, of course. And the second is you get less control over your cluster. Okay. um, for example, you want to change your networking, you want to change your storage, you want to change your runtime. There are different kinds of runtime. There's Docker, there is Cryo, there is Containerd. So if you want to change that, so that's a very lump sum overhead added to it, because these things are being managed by the cloud providers itself. So when you want the customization on your infra level also, then you go on this on-prem options. So on-prem, you get the bare servers or the vanilla servers. I'll show you the example of on-prem to make you understand the Kubernetes thing properly. So in this, we will configure the master node as well, we will configure the worker nodes as well, we will create these components, then these components, and then we are able to deploy applications over it. So it all, every solution, I'm not saying it's a limitation, every solution has its own pros and cons. So it's depend totally on your workload, like what you want to achieve. With that said, you have this infrastructure in code cloud. Like for example, in our company, we go with both of the options for different kinds of project. We also go with the GKE, we also go with the EKS, we also go with the on-prem options as well, because learners are from wide variety. Okay. So yeah, that's the thing, cloud managed versus on-prem. Okay. Okay, this is the interesting one, because we are going to see a demo on K3s. So it is important to understand what K3s is, and what are the differences between K8s and K3s. So anyone like who didn't know why we call Kubernetes K8s, it's a silly thing, but yes, good to know. Between K and S, Kubernetes, Ubernetes are the 8 letters. That's why we call it K8s. And why we call it K3s? Because cubes, Kubes, so Ube 3 letters, that's why we call it K3s or cubes, whatever you want to correlate it with, but this is the logic. So when we are going to use K8s and when we are going to K3s, right? So Kubernetes is an industry standard. K3s is a lightweight Kubernetes. It's completely what Kubernetes offers, but in a lightweight. It doesn't require that much amount of CPU and RAM. I'll show you the documentation of installation of K8s cluster on the bare metal. You will be amazed to know that before deploying the application, you have to go on through a complete entire documentation written over the internet. Okay. And still there are high chances that you might not achieve clusters, stable clusters in one go. That's what happening to us more oftenly, right? So K8s is complex. As I told you, there are so many components, but K3s runs as a binary. So one who don't know about binary, you can correlate it with the exe file. So whenever you install games or something like that, there's an exe file which you run file, right? And that file installs the entire application. Similarly, K3s has its binary file. That binary file compiles of all the components. It has API server in it, it has controller in it, it has scheduler in it, so you don't have to worry about um, installing these each and every component separately. Now KTES use kubeproxy. So I told you kubeproxy is a network management tool, while K3s uses traffic is a again a network management tool, but adds up capabilities of network management and network policies as well. I think so. It added network policies as well, but it because it has flannel. I'll not go into that deep, but yes, if you had questions, we can. I'm ready to discuss on that as well. Now on Kubernetes, these three terms you will hear a lot: CNI, CRI, and CSI, right? So simply NCNI means networking. So the component which is handling the networking in your cluster is CNI. CRI means the runtime, the container creation. Because I told you Kubernetes is just the cluster management. It does not create the containers on its own. It needs help of CRIs, which creates the container. So Docker is a CRI, Container D is a CRI. Okay. CSI, which handles the storage. So any pod you are running and you need to hold the state, so you need to attach a storage to it, anything storage, a local storage, or you want to a cloud storage. So that request is served by the CSI. So when you talk about creating a Kubernetes cluster, you have to create these three components as well. But when we talk about K3s, they all comes default in that binary itself. So again, it's lightweighted because it has tested and installed the only ones which are, lightweighted and fully compatible with each other. So it's a very quick process to create it. Finally, the HCD. So I told you HCD is the key value store. So we can also store key value in the SQLite. So K3s uses SQLite or SQLite, what you say. Sorry. Okay. So I believe you get the good idea of K8s and K3s. Don't create K3s as a new domain or a new technology. It's a new tool, but it's just an advancement of Kubernetes. It's just a lightweight Kubernetes with everything installed in a single binary, right? I'll show you the differences in action as well, if time permits. Let's see. Okay, so this is a control plane. This is a Kubernetes K8s cluster. It's not the K3s cluster. It's a K8s cluster. How it looks like. Why I haven't created it in front of this session, because as I told you, there are so many things to configure at once. So it would take might a whole day of me, and I have a nature that I am only done when the things are done. Okay, so I would not let you go as well until we achieve every pod in the running state. Okay, so this is a closer look. Like I have created a cluster last night, a sample cluster. That cluster, and if you want to create, you can use the any online shells. Like you can use code cloud. Like I'm not promoting that much. If you if you see ki yaar ye banda is only going off to through a sales pitch, no, you can go to other tools as well. You can type Kubernetes shell online and you can find so many websites offering you the shells. There you can explore how these pods are created, what these pods contains. Okay, that's a homework for you, because as much as you go into these components, I'm ready to answer your queries once you go through it. And tell me what issues you get, what things you want to know. So a very quicker look what these components are. So we studied about Cube API server, right? So there is a pod named Cube API server running, right? You studied about Cube scheduler. There's a pod running with the name Cube scheduler. Okay, there's a netcd pod running, there's a controller manager pod running, there's a Cube proxy running, right? So when we talk about Cube K8s or Kubernetes, these things we need to install manually, because these are needed for a cluster to run. If any one of them deletes, your cluster will stop working properly. Okay, so do not mess up with them until and unless you are asked to do so. Okay, so this is about control plane, how control plane looks like in Kubernetes. Okay, I think the next one is the demo. Okay, so for the demo, what we are going to do is, I have a sample application. I think I have an image here as well. Let me show you my Unity gaming skills as well. Okay, pro gamer. Yeah, application is running. See how interesting this game is, right? So this is the game. This is currently running on my local host. And what is an intent that I want you all to play this. So for this, what I'll do is I will create a Kubernetes cluster and I will deploy this application on that cluster itself, and we'll try that you all play with it. Okay, so like simply we are going to deploy this application on the cluster, and we are going to create cluster from the scratch. Few things I have created. Now what are those? I'll show you in this upcoming demo. Okay, so this is the application. Nothing like a rocket science, simple application. Okay, okay, so for this, yeah, let's start with this only. So yeah, this is my Azure portal. Okay, you can go with any cloud you want to. I just created two machines on it. These machines are one is control plane and the other one is the worker. So it's a single node architecture where single master node architecture, where one is the master node and the one is the worker node. Do not make yourself confused with the control plane and the master node. Both are the same thing. Okay, so one is the master node which holds the master components, worker nodes which holds your application. Okay, so these are two machines. I think I have to I already have started these machines. Okay, so configuration is very simple. There is two. These machines are simple machines, which have 2 gigs of 2 V CPUs and 8 gigs of memory. Similar for the worker, 2 V CPUs, 8 gigs of memory. I always insist students and even the professionals that whenever you create something, just don't rush up yourself onto any YouTube or something like that. Go through these documentations. Right. This is a actual documentation of installing CubeADM. This is the actual installation document of K3s. Documentations makes you learn a lot of things. Okay, so try to read documentations as much as you can. That's my very simple and cute advice, okay, to everyone. So these are two machines. You get the idea of it. Yeah, so what we are going to do is I will go on my shell and I will SSH into these machines. Mm, I think I forgot the password. This would be in the history if a speaker forgets the password of his own machines in mid of the sessions. Let me try. Okay, yeah, I remember it still. So this is the worker node. Let's SSH into the control plane as well. I'll put this here. Sorry, I can't give you access to my control plane nodes, but yes, these are the simple machine, and I don't think it is a astro science or a rocket science to create the instances. Even you can do on your own simple machines as well, right? But yes, for a demo purpose, I have used the completely separated machines, right? So to demonstrate it properly. So I am currently into these two machines. Let me increase the size to improve the visibility. Right. Okay, cool. So I think things are visible now. So now we want to install a cluster. And as I told you, we are going to use the K3s cluster. Okay. Let me kill this. This will use unnecessary memory on my system. Okay. All right. So as I told you, I'm not going through any blog or something. We just directly jump into the official K3s website. And all it asks you to run a Kubernetes cluster is just this command. So this was the main motive of this session, to demonstrate you that how we can create the cluster in minutes, right? This was the way back old when it takes a day or two or a week to create and set up the infra ready clusters, and then that cluster can be used somewhere. Okay, but now it's a very easy task. You don't have to puzzle yourself into this thing. You can see here just a single command and my Kubernetes cluster is ready, right? Ready to serve the traffic even. Okay, but we will also add a worker to it. So whenever you create a cluster with K3s, by default it does not places your kube config files. So what is kube config? Kube config, you can say it as a key to your cluster. To access your cluster data, you need that config. Okay, so where this config is, this config, I think it's stored here. Rancher K3s. By the way, Rancher is a K3s is a Rancher tool. Rancher is an open source tool for storage and cluster management again. So this is my kube config. So you can use this kube configs to access your cluster, right? So this is kubectl. I can give an argument called kube config. I'll mention the file name, and sorry, there's nothing still here. So you can see I can access my cluster, and currently this cluster have 4 namespaces, the simple namespaces. I'll show you the what's the data within this cube system namespace. Cube system is the important namespace because all important components are stored into this particular namespace. So you can see here, it doesn't have those much of pods, to manage, which I have already shown you here in this slide. right? You can see here Cube API controller, a scheduler, and everything. Here, nothing you can see here. Okay, there is only core DNS. There is nothing else. Traffic, as I told you, is for cluster. It's a replacement of Cube proxy. Traffic is there, traffic or what you call it, and no components are there. Basically, it runs a K3s service. So if you are familiar with simple Linux, you can see this service here. So this service is running. This is a binary. This binary have everything in it, right? It has the Cube API configuration, it has the scheduler configuration, it has SQLite configuration. You can everything you can see within this service. Okay. um, this is how you create a cluster. Now cluster is ready, we can share the traffic. But when you go into the production, this is a very good question asked by the interviewers a lot of time, that whether or not you can install your applications on the worker nodes. So what you will answer? So answer is yes, we can, but answer is no, we should not. Right? Yes, we can, but we should not, because control planes or the master nodes are the critical nodes. We should not deploy our workloads, our application on it. This should only hold these important applications, right? Only these important applications. Other than that, everything should go on your workers, right? Because as I told you, applications can crash anytime, right? Anything can happen to your application. We are not what we call it, we're not bhagwan, we are not anything. So your code will blast anywhere anytime, right? So at that time there should be issues like memory leaks or the out of memory. This could cause your control plane to go down as well. And as I told you, if your control plane or master node goes down, nothing can save you. Nothing. It's very typical to get your cluster back into the action. Okay. So yeah, we are ready with this. Next thing is to add a worker node. So again, a documentation, and I've already opened the link, but you can just Google it up, and it's very simple. Just go and write K3s, and it's an entire documentation. This is an installation guide that I've opened. This is a quick start guide, and I really want that you guys should create a cluster, deploy your workloads on it, and just present it to me. I would be very happy to know that yes, you are able to work on these stuff a lot. Okay, so this is a command basically, guys. So whenever you want to add a worker node, you have to run a similar script. You see here the script is same. The only difference is it has a URL. This is the master node URL and a token. So token is used to legitimate the request, that yes, authorize the request, as I told you about the API server, right? So just copy it down, and we are going to run this command within this worker node, but we have to replace this token. So where do we find this token? This token is found again in this worker, in this control plane. So you don't have to go like worry that you have to remember this thing. This is mentioned in this document itself, that this will be found on this path. So I will go and just uh, copy entire thing, and I will paste it here, and it will ask me to the server URL. So in production, guys, we should not use the public IPs. Currently you can see on my Azure that I have assigned the public IPs, so my cluster is vulnerable to the attacks. But in production we do not assign the public IPs, we use load balancers instead, or we use the bastion host or jump host servers to access the clusters. Okay, so this is my control plane IP. For a demonstration purposes, I'm using the public IP here. So this is the whole command which will do the magic. This will install the cluster. This takes the class control the cluster URL and the cluster token. Okay, just we'll press enter and just wait for a bit to add this thing to our control plane. It's starting a K3s agent here. Agent is, again, as I told you, is like a kubelet service, kubelet that we have seen in that diagram. Okay, all right. So let me again try to get if my node is added or not. So when I type the command kubectl get nodes, so here you can see there are two nodes already, control plane and the worker node, which is added just 14 seconds ago, which is this one. So yeah, this was it. Like, we have created the cluster, and I don't think it took more than 5 minutes for spinning up a new cluster. And that is the magic that we do when we get the request from the different thousands of users in a minute. Not only this, there are few more things, but yes, initially this is the thing which we serve. You can also check the cluster provisioning speed on code cloud as well. So this is how the cluster is created, and cluster is ready to get all the traffic onto it. All right, so now cluster is ready. Now what happens if you try to install this cluster as a k8s cluster using kubeadm? So like k3s has its command line utility, kubeadm is the another command line utility which is used with for installing the Kubernetes. So you can go through this documentation. That's a vast documentation which are ask you to do so many things, right? It asks you to check the network adapters, it asks you to check if the port is open, it asks you to disable the swap because Kubernetes doesn't works with the swap memories, and it asks you to alter the fstep entries. It then asks you to install the container runtime. In case of our these clusters, container runtime is already installed here. When you check, I believe it's container D. Okay, so it's not running as a separate service. Container D is the container runtime for K3s. So here it asks you to install that as well on your own. It will not install, right? Similarly, you install more kubelet, kubeadm, kubectl, right? This was only the installation part. Another document mentioned how to create a cluster. So this again has again a more documentations over it. I'm not saying that it's hard, but yes, it's a time taking process. It takes a lot of your time to install and set up a completely functional clusters. Okay. So yeah, this was the documentation, and k3s installation is done. Now let us try to deploy our application, the application which I have already told you. Okay, so I think I have the complete file present here already. So let me I think you should know, I believe that you should know about YAML, yet another markup language. It's like a JSON where we mention our configurations for the kubectl to apply the Kubernetes manifest. So first we will create a namespace. Namespace is needed for the isolation. It's a component. Then we use the deployment. So deployment is the another component, or this component is basically, just give me a second, guys. I think there is some issue in my network. Just a second. Sorry, I'm back. Okay. So I see so many chats here. Okay. I will jump into chats later. Okay, so we create a namespace first, then we have deployment file. So this is the basic application. So you can see the same image is mentioned here. This image will be deployed as a container, or as I told you, this is served as a recipe to the customers, and you all are my customers today. Okay, and then we will create a service. This service is created as a node port. There are three different types of services. I'll not deep dive into it, but yes, there are cluster IP, node port, and load balancers. Based upon your need, you decide what you want to. So node port, I have mentioned the service name. Okay, so what we'll do is we'll try to deploy this application. So for this, the command you want to run is apply -f and the name of the manifest, which is app.yaml. So yeah, this one is clear. Just deploy it. Okay. Okay, so path is different. I have to change the path of this K3s YAML. So what was the path? Rancher K3s. You can also mention your kube config in some in the directory called .cube, but I'm not doing that for the sake of simplicity. But you can do that. This is how you write a command, and let's try to rerun it. And here you can see it deploys the application for me, right? So I've deployed the application in the namespace. Let us see if it is deployed properly or not, and the pods are in the running state. So what I'll do is I'll do -n as we have used the namespace, right? And I'll do get all. So here you can see one pod is running. This is the pod, which is the application pod. A service is running. at the type node port, and we can access the application on this port 3001. Okay. You can also try to access it, and you are able to access the application. I'll show you the URL, of course. And then there's a deployment, and there's a replica set. Replica set is just to manage the replication. If request increase, I will increase the number of pods to cater the traffic. Okay. So yeah, our application is deployed. Let us try to access this. So one more thing here, as I mentioned, the node port, the means it means that application is deployed on a particular node. So here it is deployed on the worker node, KK worker, right? If I have multiple nodes, it would mention which node it is deployed. So on that particular node, this port is exposed, and only on that node IP I can able to access the application. So here, if I try to access this application from the control plane, I would not be able to do so. Yeah, right. So I have to use the IP of this worker node. Okay, so this is the IP, and the port is 3001. Yeah, so yeah, my game is online. Just rate it on the Play Store. Okay, and try to access it. This is the URL, and yeah, I have shipped my application completely from nothing to everything. We have achieved, right? We created the cluster, we shipped the application, customer is happy, we are happy. There are so many other aspects to it, of course, like security, optimization, and stuff. But yeah, this is the pretty much when you start with the things, and this is how you create the complete mess. Right? That's how I started. Okay. So yeah, this was it, I believe. Yeah. So I think I have done with the presentations, right? Okay, so next is the Q&A. So anyone who wants to connect with me, you can just connect with me on LinkedIn, and this is my LinkedIn QR. You can scan it and just connect with me, or take a screenshot, whatever you like to. And in the meanwhile, if anyone have any doubts or something, sorry, just do let me know. Yeah. I can stop sharing. Yeah. Okay. Yeah. Shoot. If I don't know anything, I'll unmute my mic. Just understand I don't know. Okay.
So I think you guys can write the question over chat, and I'll ask Abhinav. That would be better.
Yeah, that would be again. Mm.
So we will wait for like 2 4 5 minutes, and then if there is no question, then we'll hand over to Rajni.
Okay.
Guys, ask question. It was really interesting, and even I learned something from Abhinav. And it,
If you don't have any questions, no need to worry. If you want to try all these things first, and it might be over
yeah,
hectic for you, so just try these things and ping me. I'm available. And if Ashutosh
yeah, yeah.
invites me, I will definitely again answer those
Sure,
questions.
sure. It will be our pleasure to invite you again. Maybe offline even next time. That would be better. You
Yeah,
can actually, like s-
take more
recall your,
time.
yeah, recall your days of Dehradun.
Definitely, I will. Yeah,
So in person is like a good thing to be.
definitely.
Yeah,
In
since
like the
we do have certain limitation, that's why we try to make it online, so that we are in just that's how we actually like be in touch with the subject. Because I
hmm,
was not knowing you, so I discussed with Michael, and he suggested, because
hmm,
for him to come, it was like time zone issue.
definitely. Yeah.
And yeah, yeah, certainly we will count Rajini also. That's not okay. There's one question from Tushar, and
Hmm.
he's asked why we need clusters. As in, like, in what context? I'm not sure what he's ask, why he's asking.
I.
Yeah,
Hmm.
his question is why we need clusters.
Okay, so as what I understand, I initially I write three things: what, why, and how. So I think I have not answered why part correctly. So if you're asking that thing, that why do we need cluster, I'll try to answer this. That every application can be shipped on the single machines. Okay, so let's say you have an application which have front end, which have back end, which have payment service, which have let's take an example of a typical e-commerce website. Okay, so when everything is running together as an e-commerce, and I'm talking about large scale, so Kubernetes is actually preferred when you work on the large scale things. So at the large scale we need clusters, because it is become very hectic when you work, when so many components are clubbed up in one place. So Kubernetes is a solution for microservices. You create a simple microservice for your app front end, a microservice for backend. With that, what you achieve is the loosely coupled services. Okay, so if something happens to your backend, you know that this issue is at the backend, and and one team is working on the backend, which is not halting the other things, right? Which is not halting the front end team. Front end team can work on it, right? It's so that is the case which I remember. Currently there are more use cases, but this is the major case where we need Kubernetes. Okay.
Okay, one more question from Simran.
Yeah.
How do we secure the cluster?
Okay, so how do we secure a Kubernetes clusters? Good question. So as I told you, what I've done here, I've used the public IPs. So do not use public things, public IPs, assign the public subnets to your cluster. Make your cluster as much as private you can. If you want to serve your application to the customers, use load balancers, use ingress controllers. Okay, so if you are new to ingress controller and things, just Google it. You will find how they work and how NAT gateways work. So in this way you can secure it. This is a paid solution. Second, secure from the DDoS attacks and those kinds of thing, right? The ethical hacking part. So for that you have shields, you have security DDoS shields, you have MITM shields. There's a service called AWS Shield. So what those service do is they create a layer over your cluster. They monitor all the traffic coming in and going out, and then they find out key we have to block it or not. So yeah, these are WAF, web application firewall. I was just recall the name. So you can use WAF as well on your cluster to secure it.
Okay, one more question.
Okay.
Anshul, that so many
Uh,
students from first year, how about their career, how they can make their career on
okay.
Kubernetes, really.
Kubernetes. Yeah.
So I think this we can discuss at the end also. But
Mm.
what are there is technical question, what are the different factors we should keep in mind when efficiently sizing the K8 cluster? This sounds interesting question from
Hmm.
Himanshu Rawat. I hope you
Okay.
got, yeah.
Yeah, I got it. So Himanshu, very interesting question, and actually this is what needed in every company. So when we talk about scaling, there are three different kinds of scaling: horizontal pod auto scaling, vertical pod auto scaling, and cluster auto scaling. So initially what we do is the companies do used to do it. Whenever workloads increase, they add a node, right? And when workloads decrease, they remove the node. So this is the way they used to scale. But now when this auto scaling part has comes in, so based on the metrics, about metrics are like your CPU and their memory utilization. So based on that, these are the simple metrics. There are tons of more metrics. So based on these metrics, they auto scale. Like if traffic goes on, they will auto scale your cluster. If traffic goes down, they auto scale down your cluster, right? Even the pods, even replicate your pod or replicate down your pod. So these things are working. And if you go into the CNCF space, there is a tool called KEDA. So that works on the auto scaling, but that is also more efficient than the cluster auto scaling. It works on the efficient business logic. I definitely will share with you the link in the chat, and you can just study about KEDA. That's a very interesting tool and just revolutionizing the industry. So yeah, fact of I think this is might answer your question.
Yeah. And what should be the size of the base node if we consider auto scaling? Or you can directly read from the chat also, I think, right?
Yeah. Size of the node, definitely, you can go into the documentation. Like there is a documentation completely dedicated to what could be the size of the node when you create a cluster. But two
Also,
vCPUs,
yeah.
4 gigs RAM, good.
So Himanshu, if you have such questions, you can write it down to me, and I will, redirect to Abhinav or
Yeah,
That can
yeah.
be good. And the thing, another question, what type of projects can we build in using K8 and K3s?
Okay. So honestly speaking, Kate as Kubernetes and cubes and K3s, these things are needed for the large scale projects, right? The projects which have so many services clubbed up together and working as a single application, right? But let's say if you have a very simple application when there is a front end and there is a back end, just simple application and no interaction and nothing like that. So I would say that you should not go with the Kubernetes. If you have heard of this idiom that jahan sui se kaam ho, let's not use the talwar there, right? So large scale application, but yes, industry mein Kubernetes is highly demanded because they have the projects which demands these microservices to cater the need, right? So yeah, I think that would
Yeah,
be
I certainly agree with you, Abhinav, on this, because like I am being a consultant from like many times, like since long time. So I see sometimes we over engineer things which is not
correct.
actually required,
Exactly,
and
definitely.
because of our maybe hourly billing also, I don't know what why they think.
Definitely,
Yeah,
indeed. Yeah. So
that,
never
that
over engineer anything.
yeah.
छोटा
So
सा
that,
काम छोटी चीज से हो रहा है, do that.
and so you can answer the last question, then we will start
Okay.
to with Ajni. That is how the person can initiate their career to Kubernetes. So
Okay.
you can answer how you actually started, so
Hmm.
that gives them motivation and idea.
Okay, I'll go quickly over it so that Rajni get sufficient time. Okay, so I started as a for Kubernetes and DevOps. I started as a cloud engineer. I started learning about different cloud providers, cloud technologies. But from that time to till now, scenario has changed, guys. You should know the basic programming as well. Either any of the programming language is good. I would say if you go with Python, it's good. You go with Go, then it's good. But at least you should have a knowledge of any programming language. You should know the cloud and DevOps. DevOps is the thing which you should start your career with. SRE is the one step up of DevOps. I started my career as a cloud engineer with some company named Sirpi, I believe it's in Bangalore. Then I switched to Zeev. I joined Zeev as a founding engineer and I worked there, and there I learned a lot of things. I learned back end, front end, cloud, DevOps, SRE, and everything. I worked there. Then I jumped to Code Cloud, and Code Cloud again is a completely on the cloud native environments. So yeah, Code Cloud is an SRE, DevOps, cloud engineer. So that was the step I took one by one. I didn't directly reach to the SRE because there are so many tools. Even when we are talking here, who knows, there are two more tools added to the stack. So yeah, there's no definite path, but yes, there is a path which I followed is the cloud, DevOps, then SRE. Yeah.
All right. So that was really a great answer, and uh,
Hmm. Like one more thing I would like to mention, that if you want to learn SRE and DevOps and the roadmap and the stuff, currently there's a free week going on in the Code Cloud. So if you want to explore, the complete platform is free for this week. There's only one day left, 17th till 17th it is. So you can try out the courses there, you can try out the labs, you can try out the roadmaps, see if it works for you. It's not mandatory to go there, but yes, see if it works for you. You can see more good tutorials out there in the market as well. So yeah, that is it, Ashutosh.
yeah, thanks a lot for your like insightful session. Even we learned a lot of from it, and I hope it answers everybody questions, and they like we do have engaging questions here and interesting
Definitely.
questions.
Yeah.
And yeah, thank you so much once again, and we will definitely look forward to host you here in Dehradun, as
Definitely.
we in the land of gods. you know
Yeah, definitely.
so we would love to welcome you, and anytime soon I'll be reaching you out for that. And thanks
Sure.
again for your valuable time. So we now I like ask Rajni to take over, and please, so sorry to keep you waiting for a long time, and now you can start with your session, and we are looking forward to gain some again good understanding. So women in tech, again, example of how the girls are changing the story. And congratulations, Rajni, and really I welcome you here, and thank you
Thank
so much
you.
for being with us in such a short notice. Yeah, so
Thank
over
you
to
so
you.
much, Atosh and Ashutosh and Mohit for inviting me. And that was really an amazing talk, Abhinav. Thanks for that as well.
All right, over to you. You can start.
Okay, sure. I'm sharing my screen. Let me know once my screen is visible. Is it visible?
Yes, yes.
Okay, so hi people, a very warm good afternoon to all of you. So this session is gonna be about what exactly is the role of eBPF in Kubernetes networking and security. So I heard Abhinav's talk and like he covered many things like what are the different components that we are having when we are dealing with Kubernetes and like what is deployment, what is namespace, what are services. So many things he covered. So in a way, basically, he made my job very easy. Okay, so in this session, I'm going to be focusing on how you can maintain security for your Kubernetes clusters. So I had seen that some people were asking in the chat section that how we can maintain security. So this talk is going to be around that only, like how why maintaining security of K8s is important and how we can do that by making use of this tool which we are having is eBPF. So around this, we'll be talking. So before getting started, a little intro for myself. So my name is Rajni, and I'm working here. I'm working as a DevOps engineer with Global Logic. And apart from that, I'm a Docker captain as well. Like recently, 2 months before I got selected as a Docker captain for my contribution for the ecosystem. Then WTO ambassador as well. So just how Ashutosh mentioned that women in tech. Basically, in this WTM ambassador, what we do, we just try to bring more and more women in tech, and then I'm a public speaker as well. I have given many talks in like India level conferences, and also I got a chance to attend this AWS reInvent as well last year. So that was a quick intro about me. Let's jump into the agenda now. What is the agenda that we have for the talk? So first thing we'll talk about what exactly is the history of this tool, that is eBPF. Then what exactly is this tool that we'll talk about, and what is the architecture of eBPF. Then we'll talk about what is the role of this eBPF when we are talking about networking in Kubernetes. Then we are having some of the challenges that we may face when we are not making use of eBPF. Then we'll talk about the best practices and some examples I'm having, and some analogies as well I'm having. And after that, I have a demonstration as well. So let's see if I'm finishing my I'm finishing my theoretical part quickly. Then we can jump into the demonstration as well. So considering most of the people here are students, I guess, so just try to keep it very simple so that it should you guys just should get an idea what exactly I'm trying to explain here. So first, let we have here is Kubernetes security. Okay. So based on what Abhinav talked, so anyone would like to tell me how we can maintain Kubernetes security? Anyone in the audience, if you know, you can unmute and you can talk about the same. We can keep the session interactive, guys, so that I'll be getting an idea how exactly your understanding is. So that will be really great for me. Anyone do we have would like to tell about security? You can talk, okay. No one is
You
going
guys
to
can
interrupt.
raise your hand or chat. Write the chat. I will unmute you if you are not
Yes.
able to mute yourself.
You heard Abhinav's talk, right? So he told about these things, like how we can maintain security.
Anybody who want to talk, like Anshul, you can talk if you want.
Okay, if not, you don't want to talk, you can type the answer as well in the chat section. Let me see.
Okay, I think someone,
Ah,
Himanshu.
yes.
Yeah, so security, for my understanding, revolves around three major things, starting with identification, then authentication, and authorization.
Mhm.
So, with respect to Kubernetes, we can have security at multiple levels. Uh, uh, for the authentication level, we can have node level securities with us. Then, if we talk about authorization, we can have multiple role-based access for different things, what a user should be allowed to do, what sort of commands he can control. And the third thing that we can have is network security in place, in which we can grant access or revoke access to particular things that we want to have access to our environment. And yeah, that's it maybe.
Okay, that was amazing answer, Himanshu. Thank you. Anyone else do we have?
You can request, I will approve to unmute those who want to speak.
Okay, fine. So as Himanshu answered, okay, when we are deploying some application into the cluster, so we have to make sure that the application is secure, okay? Because suppose if you have not taken care of the security aspect, then you can expect some malicious activities that can happen to your application, or unauthorized people can access your application. And suppose by any means they are getting access to your cluster, okay, so they can get into the cluster, they can make changes into it, and based on their requirement they can update your cluster, and this can eventually harm the application which is working in the prod. So that is one of the major reason that we have, because of which we need to make sure the cluster security is managed. So talking about how exactly we can do this by making use of eBPF2. Okay, so I would like to give a real life example here, and you can just I'll just again tell how you can compare the same real life example with the terminologies of Kubernetes, so that it will be easy for you to understand what exactly is going to happen here. So you can consider that you are living in a big apartment complex, okay, and you are having hundreds of flats in that apartment. And when we are talking about flats, so these flats you can consider as the containers or as the pods. So pod is one of the component of a Kubernetes, okay. So and this each flat that is basically the pod. So this will be having its own people living inside. That is basically each pod will be having its own application and service that is running inside that pod. And when you are talking about the apartment, okay, so multiple flats are there, and people from one flat they can visit to another flat as well. And this basically is called as network communication that is happening between the pods. And not just the people who are living in the apartment, but also you can expect some delivery guys can come to your apartment, or you can ask your friends to visit your place, or some strangers can enter the building. So these kind of scenarios can happen. So this is basically called as the traffic that you are receiving from the outside world to your cluster. So this is how you can relate the same. So, what exactly is the key problem here when we are talking about the apartment example and we are comparing the same with the Kubernetes? Okay. So, first thing we can talk about is finding the right flat. Okay. Like, for example, consider that you are not having flat numbers on the flats which are there in the apartment. So, if no flat numbers are there, then of course people will just keep walking around and they keep asking you, okay, where is this XYZ flat? Because numbers are not provided, so it's going to be really tough to identify that particular flat with the particular number. So this is one big issue we are having, finding the right flat. And in KATS terminologies, this is basically called as service discovery. Okay, we have to make sure that the request that is coming to your cluster, so that should be going to the right service, it should be going to the right pod. So this we have to make sure. So that is basically we have to maintain that right service discovery is provided. And second thing we can talk about here is how you can secure the apartment. Okay, again, when you are thinking of securing the apartment, you have to make sure that you are maintaining the things like security guard. You can consider a particular person which is dedicated, and he'll be standing at the gate and he'll be taking care which is the person who is coming in, checking the ID cards and stuff. So these things you can implement when you're talking about the apartment example. Okay, and if whenever there is any stranger or a thief is trying to get into your apartment, so then that watchman can like basically avoid that person's entry. So this is another issue we have. And then we can talk about one more issue, that is monitoring. Okay, we talked about service discovery, then security, now it comes to monitoring. So also you have to make sure that you are having a track of who is visiting your place. Basically you can achieve this by implementation of CCTVs, or you can keep the visitor logs. So many things are there by which you can keep a track of who is visiting your flats. So when we are talking about this apartment example and comparing the same with Kubernetes, okay, so finding the flats, so we can say that this is basically service discovery, okay. Then security of the flats. So for security we can say that in Kubernetes terminologies, we are having network policies to maintain the security. And for monitoring, we are having observability things in Kubernetes. That is basically the inspection of the packets, and you can trace the flows that is coming. So this is basically the issue that we are having. Okay, so see, there are main three things that we need to take care when we are talking about KATS security. First one is service discovery, then we have network security, and then we have the observability as well, basically the monitoring thing. So these are the three things that we have to make sure we are keeping a track on when we are planning to secure the Kubernetes. So let's get into the tool now, that is basically eBPF. So eBPF long form is Extended Berkeley Packet Filter. So this is a very powerful technology that will allow user to run sandbox programs in the Linux kernel without making any change into the kernel's source code. Okay, or there won't be any need to install any or load any modules as well. So it is going to give you that capability that without making any change into your kernel's code base, you can create some programs and you can run these programs on top of your kernel in a sandbox environment. So this eBPF basically is going to act as one of the modern AI powered security system that you can install to maintain security for your clusters. Okay, and this tool is used for networking, for security, for tracing the packets, and also when it comes to monitoring the performance as well. So there are many things for which you can make use of this eBPF tool. Okay, and talking about the history of this tool, so this eBPF was created in early 90s, and the main motto of creation of this tool was basically to develop. It was developed to filter the network packets, okay, which are basically which are coming to your kernel. So basically to filter the network packets it was developed, and it gave us a feature by which we were able to capture the packets network packets directly from the kernel level, and this provided better performance, better visibility into your logs, and again when we are talking about the monitoring as well. So these are the many things eBPF get us a thing that okay, so making use of this we can keep an eye on all these things. So this was about the history. Talking about the future, so as time passed, so people started like adding more features, and they started basically advancing the BPF tool. Okay, so earlier it never supported the high level programming languages like C, but now eBPF programs support high level programming languages like C, and the program that you want to write for basically maintaining this security and networking stuff, so that you can write in C lang, which are later compiled into bytecode, and later on it gets verified for the safety before it's running into the kernel. And using this we are not just eBPF, but we are again having some things like Cilium we are having. So using Cilium we can enhance this functionality that eBPF is doing when it comes to profiling of the application, when it comes to observability, when it comes to DDoS protection. So for these all kind of things we can make use of this eBPF and Cilium as well. And apart from this also I have seen there are many plugins provided, many another tools again we are having, which are again helping us to bring more security and to track the entire performance of the cluster as well. So this was about what exactly is this tool, and what was the history, what was the issue that we were facing, and how we created this tool for resolving those issues, and how it, as time passed, how we evolved into this tool, and how we brought more and more new features to support the current development. So talking about the overview of EVPF, so I have specified here four components. So we can talk about these four one by one. These are basically the components of architecture. So here is the architecture. We'll talk about this. So before getting into this, we'll discuss about what are these components now for EVPF. So first one we can talk about is the eBPF program that we have. So these eBPF program are written in languages like C. So we talked about this, like how it is now supporting high level programming languages like C, and you just have to write the program, and then it gets compiled into eBPF bytecode. So this is how the compilation process happen, and these programs of eBPF are loaded into the Linux kernel, and then they are executed in a JIT compiled manner, that is just in time compiled manner, for providing the high performance. Then we are having KVM, that is a kernel virtual machine. Okay, so kernel virtual machine is nothing but the Linux kernel is going to have an eBPF virtual machine that will be running your eBPF programs inside a sandbox. Okay, and it will again make sure that before the execution of these programs, the kernel will verify if the program that you have written is safe or not. So this is basically ensured to to avoid any kind of crashes, or to avoid any kind of unauthorized resources as well. So this was about the second component that we have, that is network interface, sorry, the KVM. So third one we have is a network interface. So eBPF programs again can look into the network interfaces as well. So basically to keep an eye on how exactly you are receiving the network packets, and you can observe the packets that you are receiving, and you can basically filter these all packets, and if requirement is there based on the performance or any issues that you are facing, so based on these scenarios, you can again modify the packets as well in real time. So this is what this network interface is going to do, and this network interface will allow users to provide like you'll be having a full fine grained control over all your network traffic. And this is again going to help you to advance to make use of some advanced features like load balancing is there, we have DDoS protection, we have firewall rules. So these kind of many advanced features are there which you can make use when we are making use of the CBPF. Then fourth component we have here is a user space application. Okay, so the application which is there in your user space, so that application can interact with eBPF programs through system calls. Okay, and they again gonna be using these eBPF programs for networking or for performance monitoring. So there are many things for which we are using these user space applications for. So this was about the components. Okay, then we have is the architecture. So what exactly is the architecture of UPF now? So you can see two blocks are mentioned here. First one we have is for this is for storage subsystem, and this is for network subsystem. So talking about the each components which we are having here. So first one we can talk about is the process. So this is the process block we have here. So this process block is nothing but it's a user space for your application, which is basically performing operations like reading and writing, receiving the traffic, and like releasing the traffic. So this is what this process that is basically the user space is gonna do. Then we are having syscalls. So whenever a process is gonna perform some input output operation, so it will go through these syscalls, which are basically system calls. Okay, and if you want to more secure, like the requests that you are receiving, the inputs that you are getting, so if you want to secure these as well, so what you can do in this syscalls, you can attach eBPF hooks as well. So that will help you with the security of the inputs that you are receiving. Then once we are done with these two, we just get into the Linux kernel. So inside this Linux kernel, we can have these eBPF programs, and this can be attached to many different components. Like for storage subsystem, we are having this file descriptor is there. We do have VFS, virtual file system is there. Then we have block devices. So block devices is nothing but it's the storage, it's the block storage that you'll be attaching. And similarly, for a network subsystem, we are having things like sockets, we have TCP/IP, we have network devices, and the another components are going to be same for that. So this is how the CBPF program can have these different components inside the kernel. Then we are having this is the storage system, storage subsystem, and this is the network subsystem. So storage subsystem can be used to observe and optimize the storage operations. Okay, and this network subsystem, so that can be used to provide a fine grained control over the packets that you are receiving over the TCP/IP stack. So to keep a track of all these input output operations, or what input you are receiving, what is the output going, so we can make use of this architecture. So, what is the role of eBPF now when we are talking about Kubernetes networking and security? So again, 3 points I have mentioned here. First is networking, security, and observability we do have. So talking about networking, so how exactly this tool is gonna help us with networking? So first thing we can talk about is packet filtration process. Okay, so eBPF is gonna bypass the traditional IP table space routing that we are having. So it will be bypassing that, and it will enable you faster packet forwarding. And again, it's gonna make sure that a very less latency is provided for that as well. And for networking, we can talk about things like load balancing is there. So we can again talk about service discovery. So service discovery again is basically used to make sure that the traffic is being received by the right pod. So this is how service discovery again is going to help us with that. Then we have security. So for security as one of the component in this EBPF, like how it is helping us with security. So we can talk about is network policies are there. Okay, so EBPF will enforce this fine-grained network access control at the kernel level, and again you'll be having a full control over the pods, like which pod and which service are, are communicating with each other. So this communication is going to be very important, and you have to make sure you are creating right network policies and right service and right pods, they are interacting with each other. So this thing you have to be very careful about. Then we are having things like intrusion detection is there. Okay, so eBPF again will help you with monitoring the system calls and network flows. And again we can talk about the different process activities which are being performed here. So for this also we can make use of this tool. And DDoS protection, so that is also important. Then we have observability. So observability is nothing but it's a monitoring aspect. Okay, so BPF will give you a privilege to get a real-time visibility into the performance, like how exactly BPF is capturing the network traffic, and how exactly the system calls are happening, and how you are making use of the resource. So these all things you can keep an eye on. So this is how EBF is playing a very important role when we are talking about either it can be networking, it can be security, or it can be the observability part. So, what can be some of the best practices now when we are dealing with eBPF solutions? So, I have listed here some best practices. So, first one we can talk about is we can make use of this existing frameworks like BCC is there, libbpf is there, BPF tool is there. So, we can make use of these trusted frameworks. Okay, basically to simplify the process of development of eBPF programs. So, we can make use of these frameworks which are provided. Then optimizing the performance. Okay, so again you can take care that when you are writing a eBPF program, so you can try minimizing the complexity of that eBPF program, basically to reduce the execution time, you can say. And you can reduce the CPU overhead as well by maintaining the complexity of program as very less. Then again we are having third one as prioritizing the security. Okay, so eBPF is itself created for maintaining security of Kubernetes clusters. Okay, so how we can prioritize security here? So we can make sure that you are enforcing proper sandboxing when you are implementing these eBPF programs. So that is how you can make you. This is a best practice that you have to like prioritize the security of the sandbox mechanism as well. Then testing your programs in controlled environment. So before pushing your program directly into the prod, you can make sure and you are testing the same program in the staging environment before it's getting deployed into the prod. And basically here in staging you can check that if BPF is verifying the right output, or what was your expectation from that program, so whether that is been received or not. So this you can check there. Then staying up to date with the Linux kernel. Okay, so you can again keep a track of Linux kernel's versions, and you can update your eBPF programs based on the updation of the kernel. So these are some of the best practices we are having. So there is this example, TCP dump. Okay, so TCP dump is basically it's a command line packet analyzer that will allow users to capture and inspect the network traffic in real time. And it again relies on BPF, that is Berkeley packet filter. It is mentioned here. So it relies on this technology to filter the packets that you are receiving in a very efficient manner in the kernel. And here you can see there are many things by making use of which you can basically like distribute, or you can create a separation among these different kind of traffics that you are receiving, like based on protocol source and destination IP addresses and ports. So based on this you can capture and you can distribute these all traffics that you are receiving. So this is a very interesting analogy that I have mentioned here. So you can see here is a static website and here is a dynamic website. So how we can like compare this example with the eBPF and the K8S scenario here. So talking about this static website which is mentioned here, so you can see the content of the static website is fixed, and the behavior is unchanged. Like even if you are making any activities here, it won't change. And if it's the same thing, we are talking about dynamic website like this Amazon website you can see here. So it is basically interactive in nature. So whenever you are gonna go to some section here like this great Indian festival, if you are on this particular thing, it will give you some results like, okay, these are the dates, you can start shopping. So some reaction it will give, some result it will give to you whenever you are trying to access any section of this dynamic website. And talking about the static website, so this website is HTML only based, and it is just displaying information about it's displaying the information, and you can't really add any input here, just how to read. There won't be any kind of write operation happening here. That means basically this is not providing any kind of interactivity, the static website. But when we are talking about the same thing in dynamic website now, so this is giving us the feature of interactivity. Okay, so this feature we can implement by making use of JavaScript. Okay, so this is how this dynamic and static are different. So how exactly we can relate this example with the EBP of now? Okay, so consider you are going with the traditional kernel, that is the static one. So here in the traditional kernel you'll be having fixed functionality, and if you want to change any behavior of your kernel, like consider you want to update the networking, you want to improve the networking we can say, or you want to add any feature for tracing the packets. So these kind of information, these kind of updations if you want to do to your kernel, so that is going to be really complex here, because when it comes to modification of the kernel source code and loading the modules, so this process is really very complex and it is very risky as well. And the same thing, like you are having the same kernel with you, but now you are having eBPF as well with you. So this both together can come, and we can make sure that this the process of updation of the networking, or you want to add any custom behavior as well, so this can be dynamically programmable. Okay, like similar to how in this dynamic website, by making use of this JavaScript functionalities, you can enhance the interactivity of your website. Okay, in similar way, eBPF is gonna help with making the Linux kernel interactive in nature, or it will help us with the creation of the dynamic nature of the kernel. So this is how eBPF is going to help us with. Because going with the traditional approach, like without eBPF, it's going to be really trouble to update the kernel's main code base. So inspector gadget tool. Okay, so this is a tool which is provided by Amazon Cloud. Okay, and this is again gonna do the same functionality, like how we can make sure vulnerabilities are reduced, and to basically maintain the security. And you can see here, like it is gonna give us the features like automated scanning of your servers, containers. And again, this tool basically refers to eBPF, like it makes use of eBPF for performing these operations. Okay. Okay, theoretical part is done. Demonstration I'm having now. Then we are having these two slides. We'll talk about that. Let me. I guess from here it won't be good. Okay. Let me just share some another screen. Just give me 1 minute. Okay, I'm sharing my screen. Okay, so this is a demonstration I'm having for this. I have a recording of this demonstration. Okay, because every time I have faced that whenever I am performing any hands-on on the go in the talk, being on the stage, so 80% of the times it fails because of many reasons. So that is the reason I make sure I have a recording ready with me for the demonstration. Okay, so let's get started. So this is basically we are checking if any existing pods are there or not. Okay, so we are having some pods running here. So we just have to configure some namespaces and deployments, but before that we will just install some dependencies. So this is getting installed. Crew is getting installed here. Okay. Installing kubectl gadget. So we talked about that inspector gadget tool, right? So this is a plugin of that particular tool. So we are installing that plugin, gadget plugin. Okay, plugin is getting installed. Okay, after the plugins got installed, we can see there's a pod running with the name as gadget here. Okay, kubectl. This is the information about the plugin. Okay, so I have a list of commands here. I'll directly go to that. Wait. Okay, so what we are doing in these four commands here, we are basically creating two namespaces. So Anubhav discussed about what exactly is the namespace and what is the deployment. So we are creating two namespaces here and we are creating two deployments. And the name of the first namespace is DevOps Days and second one is Kerala. And we are creating two deployments in the same. And this command is expose command. You can see here expose deploy nginx. So this command will be exposing like this is basically created. This will create a cluster IP service that will be exposing the nginx 01 and 02 ports that we are having here. Like 02 is here, 01 is here. So this command will expose the nginx 01 and nginx 02 ports in internally within the cluster. It will expose. Checking the pods again. Okay, you can see there are three pods running now. DevOps days, we are having gadget and the Kerala one. So these three only we have to focus for now. What we have next? We have to test the cross namespace communication now. So the two namespaces that we had created. So we are going to check what is the communication between these two namespaces now. So this is, we'll first check the first communication. So by default, the communication between these two different namespaces will be open because this is the policy that by default the communication is going to be open. Okay. You can see this command kubectl gadget advice network policy monitor DevOps trace. This was the namespace that we had created. So what exactly this command is doing? So here we are using this inspector gadget tool that we had installed, and this will be used. This will be used by eBPF to basically hook into the Linux kernel and trace the network packets without modification of the application. And once it is basically capturing all the traffic patterns and the traffic type, it will record all these network interactions in this file, network trace.log file. So it will capture everything in this network trace.log file. Okay, it is recording the traffic now. Okay. Okay, what is this command? Okay, so using this command, what we are doing, we are basically triggering a cross namespace traffic from the Nginx 2, which was there in the Kerala pod, and the DevOps race wala we had Nginx 1. So we are basically simulating a traffic between between these two different namespaces now using this command. This will generate real-time network traffic, which will be captured by this eBPF gadget tool. Okay. So among these two different namespaces that we had created, we are deliberately creating some traffic here that like basically to achieve the main target that we have, that the gadget tool should be capturing the traffic that has been received. Okay, so it will be stored in again this network trace.log file. Okay, so you can see this is the file it created when we simulated the traffic between two different namespaces, and this is the file which got created here. Okay, so this is the policy that got created, and this generated network policy will allow only traffic can travel from Nginx 02 in the Kerala port to Nginx 01 to the DevOps race, which is basically on port 80. So this is how we simulated the traffic between these two different namespaces now. And once we are done with creation of this network.log, if you see the previous command here, okay, this is the log we have, and okay, here we are creating the network policy. Okay, this is the network policy. So based on the logs that are being stored in this network trace.log, so we will create a network policy now. Okay, so this network policy will basically will be created depend on what exactly eBPF traced, and what is the analyzation that eBPF did, and how it generated a minimal and least privileged network policy based on the actual traffic patterns. It will create that network policy, and this created network policy, okay, this particular network policy, so it will only allow traffic from Nginx 02 in Kerala to Nginx 01 in DevOps space that we had, and that will be exposed on port 80. So this is how it will automatically create a network policy by giving least privilege. And once we are done with this creation of this network policy, you can just simply apply this network policy, and then you can verify how exactly the traffic is moving from the one namespace to another namespace. So this is how we can create this network policies based on the traffic patterns that you are receiving. Okay, so this was the demonstration I had. I have two more slides. Okay, so this slide you can see. So this will basically tell what was the initial observation that we had, and what is the later, like once we created that network policy. So what is the scenario now? So before you can see like we had these three namespaces here, Kerala DevOps trees, and this, okay, this got repeated, I guess. So this was the target namespace we had, and this was the traffic status which was allowed previously, because I had told that by default all the traffic will be allowed. This is the default policy we had, and what traffic is now restricted once we created the network policy. Okay, so you can see the default one, this got blocked, and DevOps trace one to, like, from source DevOps trace to the first namespace to the same namespace, so this traffic also got blocked, and cube system to DevOps trace, so this also got blocked. And what is the traffic that is allowed now based on the network policy that got created using this gadget tool? So this was the only traffic type that was permitted here, like from only from Nginx 02 to Nginx 01 on port 80. Okay, because the traffic that we had simulated between these two namespaces, so this was the traffic that we had simulated. So based on that, it created a network policy, and once we applied it, it will only make sure that particular network is only allowed to travel between one namespace to another. So this is how it is helping us with maintaining security for networking. And there are some tools in the market which are actively making use of the CBP of tech. Okay, so we are having tools like Cilium is there, Falco is there, this is logo of Hubble, and we are having Bumblebee. And apart from these, like many tech giants in market like Netflix and many more companies are there which are actively making use of this EBP of technology. So this is really interesting, and you guys should definitely go ahead and check around this, how exactly it is working, what is the architecture. So I just tried to summarize, give you guys an intro to this tool. You can just go and you can try exploring more. You can check that official documentation as well. And that was the session from my side. So I hope you liked the session. So if you have any questions around the topic, or in general, if you are planning to get into this DevOps and cloud industry, so you can of course reach out to me on my LinkedIn. So you can just scan this QR code if you want, and you can ask me any questions if you're having any questions now.
All right, that was great session, and again a learning for me as well. So first of all, I'll ask some question because that's quite related to me. Like you list down that we do have some tools like Falco,
Mm-hmm.
but in terms of like exploits like zero day attacks and all that, how we are working on it? About like zero day attacks, those who are not yet known, and so
No, actually, I'm not familiar with this attack. I have to
okay.
check on that.
All right. So basically, for vulnerability management, how we are managing it, like VAPT and pen testing, how we are doing for this.
So basically, you saw how exactly what is how it this tool is basically different from the traditional approach that we are having.
Yeah,
Okay.
like the CNI plugins in Windows.
Right, exactly. It the all magic lies between in the EBP of program that you are writing. Okay, so there you have to make the configurations.
But since it's getting the kernel level things, so if anything goes wrong, like a bug or so, the person gets the root access. So that's
So
again.
okay, so I talked about the best practices, right? So there you have to make sure first of complexity always we can check, and before implementation also this EBPF architecture is made in that way that it will make sure like if you have not implemented any wrong things.
And yeah, fine. That's okay. I would like to explore it more. So, like, you have this repo also for this, right? EPF. I'll do it.
Uh, okay, like the official documentation will be fine. I feel
Okay.
you
All right.
can.
So anyone else have the question? And thanks for answering. So that was really a stupid one because I didn't know.
No,
uh,
it's fine. Like even at some point of time, this tool was completely new for me as well.
okay. Okay. All right. So do we have any other questions here? I You can write over the chat. I'll.
Let me see if there are any questions.
Yeah, sure. Okay, there is one
I can
question.
sense that maybe this topic was a little too much considering you most of the people are students here.
That's
So
okay, but there's some question from Tushar, and he's asking what is the difference between tracing EBPF and networking EBPF. Tushar.
tracing. Okay, where he asked the question?
Okay, maybe he sent directly to me, so that's why I just hold on. I'll write the question here in the chat, public chat.
What is the difference between tracing BPF and networking BPF? Okay, so when we are talking about tracing, okay, so tracing basically is we can make use when we are planning to perform things like performance monitoring or any debugging you want to perform, or you want to have some idea about your observability. So this is basically related with the tracing eBPF. And for networking, you can say things like packet processing. We have filtration of the packets, that network packets you are receiving, and you want to perform some network security. So this can be this can we can say about networking eBPF.
All right. So, do we have any other questions? Okay, so I don't see any more questions here, and I like Rajni. Thanks for your time, and it was really a wonderful session. Even I learned few things from here, and I would like to get in touch with you again regarding this. It
Sure.
was great, and yeah, I hope everyone enjoyed it. So, anything you want to tell us, or have,
Yes. So I would really like to thank Ashutosh and Mohit for inviting me here. So that was really an amazing experience. Okay. So also I have never visited Dehradun. So of course I'll be like it will be really great for me if there's some opportunity where I can travel there and give some talk in person. So that will be really great. So that I'm looking forward to. And
sure,
thank you
sure.
for
Next
inviting me.
time we will do consider, and we are planning something offline next time, and yeah, very soon.
Yeah.
And I would appreciate if you would share this and increase our follower count because that's also works.
Sure, sure, sure thing.
All right, all right. Thanks. So we are having our last day of the speaker, but not the least one. So welcoming Paji Taspal Singh. So if you can hear me, you can take over.
Hi, Ashutosh.
Hello.
Can you hear me?
Yes, I can hear you.
All right. Cool. Thank you so much for inviting me. Last but not the least, right? Uh, it's tea time. Okay.
No, no,
It's past 5, and I think people are grabbing their tea or coffee. So let me switch on my, yeah. Okay, cool.
so to give the introduction, and he is the I believe associate director or
Yes,
in
that's
UBS.
that's
Yeah,
right.
in
Yes.
UBS, and that's a bank, highly prestigious bank, and he's been in this industry over more than a decade, and he would certainly give you some insights, of like technical insight also, and also how to get into the get first job, or because he also interviews a lot of freshers, right? If I'm not wrong.
Yes, that's correct.
All right, so over to you. Not taking much of your time. Thanks.
Yeah. Thanks. All right. Uh, Thanks, Ashutosh, for that quick introduction. Okay, where's presentation? Okay. So everyone is able to see the PPT, right? Just confirmation.
Yes, we can.
Yeah. Okay. Cool. All right. See, given the audience, I'll try to keep it simple, right? Rather, uh, Abhinav and Rajni, those were really great sessions. I hope the audience have something to take away from it, as well as me, learning some key points from your sessions. That was really cool, right? uh, so I'll now start with my session now. Right? So yeah, as the title was already announced and everyone know, now I'll talk about full stack observability with OpenTelemetry. Basically about traces, logs, and metrics. You will hear these three keywords, everywhere, and we'll talk about these three words a lot. Okay. Uh, I think I'm from Hyderabad. I'm native to Hyderabad. I'm born in Hyderabad. So I've been to North quite a few times. But yeah, I'm working as an associate director for architect at UBS Swiss Bank, and I'm also organizer for Gamma and
Yeah,
Friends
Uh,
Hyderabad.
Simple,
there's
Yeah.
some issue
sorry
with
to to
voice.
interrupt, but there is your voice is cracking actually.
Okay, now is it better?
It's very,
No.
Still? Okay. Now is it better?
yeah, I think better now. Like you
Better?
can.
Okay. Okay. Can you hear me now? Better, or is it still cracking?
Yeah, it seems fine now.
Seems fine. Okay, good. Let me go to presentation. Right. So as I was saying, I'm organizer for Grafana and Friends Hyderabad, which is official community of Grafana Labs in Hyderabad. I'm also chapter lead for Global AI Hyderabad, which is sponsored by Microsoft. So I've been, it's I think about an year I started attending meetups, and and now I'm at a stage where I'm delivering talks, right? All thanks to these meetups, and I really appreciate people who have joined today. This is a great opportunity to learn, network, connect with people, and grow your career, right? Go to jump onto the agenda now. We will just go on to the introduction for what is full stack observability, to give you just of given the audience. I'll keep it again simple to make you understand how enterprise application, the industry applications can be observed. What is full stack, right? And core pillars of observability. Open telemetry, which is a highly popular tool now in a CNCF project. It is on the second number after Kubernetes. And so this is open source tool, which is now getting really popular given the architecture and the way it handles the traces, logs, and metrics, right? And then we'll see instrumenting an application for tracing, logging, metrics. Basically, a demo where you'll understand how the data is captured, how traces can be viewed. Logging, we all know, logging is a traditional way of metrics, right? So this is sorry. Uh, okay, how can I stop? Okay, what I'll do is there's a funny clip. I found it very interesting. I played it in my last talk as well. So let's have a quick view of the clip, and then we'll talk about observation important. As I already said, right, Kubernetes is just related to brain. So if brain stops working, none of the resources can actually work properly, right? So we are like brain dead, correct? So if Kubernetes is down, I mean the orchestration process, or how Abhinav has given us details of Kubernetes, right? The different components of Kubernetes. If those goes down, the infrastructure basically, your application will go down ultimately, right? So but infrastructure is important, and your application is also important. Now application has got so many programming languages. Apart from that, we know application to in the modern day infrastructure architecture, sorry, the microservices way it is deployed. The UI service is deployed as a single microservice. Your backend service is deployed as a single microservice. Given your caching mechanisms like Redis is deployed as a single service, then you've got your Kafka, which is a message-based application, as a single service, right? So there are so many components now in modern day architecture, and all are API-based applications. They are exposed APIs. Now, how do you monitor this, right? So we'll deep dive into it. That's why it is important to have a full stack observability to monitor your applications. Right? Now, challenges are now distributed, as I was explaining, right? The distributed systems. We have microservices, cloud native environments. We have third party. We have our load balance like Nginx. We have service mesh. Istio is a service mesh. I'm trying to keep it simple, but to understand observability, right, the distributed systems, and given the microservices architecture, right? So these all components, I have to mention. And if the audience, right, who are I mean, they graduated, and they are not able to understand, it's fine, but I'll try to make it simpler. You can get back to me with your questions later on, right? Okay, so traditional monitoring tools are insufficient to detect issues like latency, service failure, or resource constraints. Okay, latency, network latencies, right, between two API calls, there might be some network lag, and there would be latency in calling, and that's where the service fails, right? So resource constraints like the memory or the storage is like out of memory. We all know, right? Out of memory issues comes in. Your storage might be full, right? So to observe your these systems, full stack observability uh, is important, is required for end-to-end visibility, right? So this was like what is full stack observability and the challenges with the modern applications. So it is critical for microservices and distributed systems, as I was explaining, right? I just try to list out a few of it, like complexity in the microservices. Each of the services might be working well, but sometimes what happens is service to service communication might fail. The subsequent communication depends on the previous communication, right? The previous payload data, which might fail, right? Ultimately, your application should work end to end, right? If any of the service fails, how would you observe them? How do you identify which of the service has failed, right? For which, yeah, it's again, the microservices and distributed systems were designed to make the application decouple, more reliable, more easy to deploy, to orchestrate. But yeah, observability is a key factor here in terms of making your application up and running, right? It's not about test or dev environment, right? Ultimately, you have to have your application in production, and it's like enterprise application, let's say tier 1 applications or tier 2 applications need to run 24/7. They can't go down. For example, internet banking, right? I have an account in ICICI Bank. I I expect that the website or the mobile app should work 24/7, right? Because I have to. It's about your financial services. You need to make urgent payment. You need to do something with a credit card or some. There are services which might require at any time, right? So for which how do you observe your system? How do you make sure that your uh, if there is an incident, how do you track the pattern, right? So all these things are important. Given the complexity of the microservices, there are many tools which have been designed, and then we'll talk about OpenTelemetry as well, right? Handling failures in distributed system, I was explaining the same. So it's all about now. For example, here I've just listed out about e-commerce system where request failed. We all buy some other Amazon or Flipkart, right? If you if I have gone till the payment gateway, and the payment has been made, but then you suddenly see a 404 or some 500 error, right? And any customer or any client would be irritated. They really don't know, okay, what to do now, right? But to understand where it failed, we need logs, or to understand where which component failed, we need traces, right? So handling failures in the distributed system, that is also important. That's overall called as observability, right? So it helps the team, the observability helps the team to navigate the increased complexity and decentralization of modern architectures by providing real-time insights that we'll see demonstration. Okay. Core pillars, as I said, right now we'll hear about metrics, logs, traces. So metrics, logs, traces are the core pillars of observability. There's one more signal called profiling. I'll not go into that for now. I'll just stick with metrics, logs, and traces. In the demo, you will see which tools we have used, and a simple e-commerce website will add to a cart, do a payment, and see the traces of the all the services. I'll also list the services in the Kubernetes cluster and show you, right? So metrics, what is metrics? It's just a numerical data points that track system health and performance. For example, you have a CPU usage, memory, as I was talking about, right? Let's say you have assigned one CPU, one core CPU, and you have assigned memory about 2 gigs, but your application user login, or let's say it's a web application, and for example internet banking, then you have millions of users logging in, in a day. You are not expecting that much, and you are not designed your system in a way to handle the traffic, right? Your CPU usage spikes up, your memory is out. How do you know how do you then how do you actually understand how your system is behaving, right? Based on the metrics. So metrics create counters, like some average, mean, all this we have been learning about, right? So those are called metrics, right? And we'll see what are the tools which are capable of handling metrics, right? Logs, right? Traditionally we all know that, just for example, like Java programming, we have log4j binary, which API, so, which logs the events of the Java. And traditionally it was logging into database, Oracle database or some database, right, as a record which holds all your information, timestamp, your maybe some correlation ID, service ID, and the log details, right? So those are logs. Logs are just the event data. Whenever traditionally what I used to do is I used to go to system logs and check based on when it occurred, the timestamp, right, and just to see what is the error and try to diagnose it, right? So logs are one of the pillars. Then traces are these are the detailed records. For example, to trace an API, right? The time API is triggered, request is triggered, originated, till it gets the response time from all the backend system, right? That is called a trace. Let's say we have UI, then we have end service, then it connects to your database. For example, PostgreSQL database in Azure. Uh, then it gets some data to the it retrieves, backend service retrieves some data, and then it displays onto a UI, right? So this is the from browser, it originated from UI, backend, or third party, or your other database servers. It gets data, and uh, it displays on the UI, right? So this is the life cycle. This is the entire trace of your application. I'll just try to compare with real life analogy. Uh, uh, let's say Dehradun airport, considering Dehradun airport, right? So Uttarakhand and all our pilgrimage places, and people from south and other places they often visit, right? Now how do ATC, the control center, right? How they see this data as, right? Now let's try to just relate metrics, logs, and traces with a real life analogy. Now the scheduled times of your of the flights, right? How much fuel is there, at which gate the boarding is starting, right? All these details, how many people have been visited to the airport in a day, right? All this data is now considered as metrics. That's why they see these patterns, and they give the tag, right? This in New York is a busiest airport, or Delhi is the busiest airport. How they will come to know, right? So based on these numbers, these matrices, they will have the stats. They will have graphs. I'll try to show it on Grafana. Based on this, the metrics, they actually try to display the graphs or tabular form, and visualize the matrices. Right now, logs are the events. Considering a passenger who has stepped into the airport, who has collected boarding pass, then security check, and has been waiting at the gate, right? Then the the boarding pass will be scanned at the gate as well, right? All the events are logged, right? And everyone is very familiar with the log. So each of the record can be seen as a log, and can be investigated. Whenever an incident is occurred, let's say some plane has been hijacked and we are looking for some person through CCTV, then the logging of his his or her wherever the boarding pass has been tabbed. From there we can see, okay, this is at this timestamp, the person has entered into the airport. At this timestamp, the person has boarded the flight, right? So those are event data, which can be called as logs. Traces, in considering a passenger, right from entering the airport till the flight takeoffs, right? So all the entire the path of a passenger is can be considered as a trace, right? So I was explaining about API, right, request. So from UI backend, then other services, and getting the response. So the you can just relate with the passenger entering airport till the flight takes off. All the execution path is called a trace, right? I'm just trying to simplify with real life analogy so that you guys can understand. Yeah. Right. Coming to our tool, the most popular tool for telemetry, open telemetry. It's it's open source. So it's CNCF open source project, which is on the second number. Yes, after Kubernetes, it has quite got traction over the couple of years, and there are many monitoring agents built on top of open telemetry. Azure has built one, AWS has built one, of course Google has built one, right? So it's a framework, right? It's a framework that allows to collect, process, and export the telemetry data from the application to any backend. Backend is like visualization, considering metrics, right? So metrics, OpenTelemetry collects the metrics and from our application, and it processes the metrics, and it pushes the metrics to Prometheus. So Prometheus is a metric collector, right? So we'll see that. We'll see in a diagram, and sorry, we'll see in that in a demo. Yeah? So it's a vendor neutral and language agnostic solution, which means it's not dependent on any programming language, or it's not dependent on any operating system. It's a agent. You can call it as an agent, and that's it's a collector. It's a telemetry collector basically. Okay, it doesn't have any storage. So we'll see that. I'll just list it in the cluster and show you how it has been deployed and other components as well. Right. So what are the core components are like API, like how Java APIs are provided, or we have Python libraries. Similarly, OpenTelemetry APIs are provided. SDKs are there. Software development kits are there for considering Java programming. Right, you can add it as a dependency in your POM or Gradle, the build tools, and it will start collecting your matrices. There's also provision to um, customize your logging, or customize your matrices, the traces. I'll not go in depth with that coding part, because it will be too much, and that's a vast topic, right? So instrumentation libraries, they are pre-built instrumentation libraries, which are again agents. It can be used as a runtime agent, if anyone has worked on Java. So we can add it as an agent in the command line, and it will start collecting your telemetry, matrices, logs, and traces by default, now which comes like HTTP clients, database drivers, etc. Okay, so if you want to give it a start, you can have that instrumentation libraries, check out the I'll also show you the official documentations. There you can there is a good documentation about how you can instrument your application without any coding. That's called no code instrumentation. Okay. Collectors, as the word says, it collects the matrices, the logs, these all signals, and runs through an agent or centralized service. And exporters are I'll show you a diagram. You'll understand better about these core components, how the collectors, and then collect the data, process, and then exports. So exporters are, for example, I've listed here Jagger, Prometheus, Datadog, right? We will see that in the upcoming diagram. Right? So how, traditionally, how collection was happened, and on the left hand side you can see some separate collection of these signals. Logging libraries were separate, tracing libraries were separate, metric libraries were separate, the agents were separate, and there was no relation between these three collection types. And it was really difficult, complex to relate between what happened between two services or two mechanisms, what happened between two a service or a backend components like database or Redis cache mechanism, or any other Kafka. Uh, so there was no relation. So there are multiple agents, separate agents. They were collecting, they were doing their job, but that data was too much. There was no way to relate between the data. uh, the time taken to resolve a problem was more, uh, uh, because tier 1, tier 2 applications, they have SLAs, service level agreements. So they have to get the application, like the support teams need to get back the application within that SLAs, right? So these became critical. uh, uh, People started looking at what are the possibilities. There were so many tools coming up, and then open telemetry was one such tool which was actually able to instrument auto instrumentation and manual instrumentation. Auto instrumentation, as I said, right? So there's a library, you just need to pass on to, I'm just talking about Java. So if you pass it as an agent, it will immediately start collecting the traces, the matrix logs from, because it has some default configuration. Manual instrumentation is something you add it as a dependency in your programming language, or as a Python library. If you talk about if you talk about scripting language, or React.js, right? So there are libraries as well for each and every programming or scripting language, right? So once we have that auto or manual instrumentation, uh, the open telemetry collector starts collecting the system logs, app logs, the traces, as you can see on the PPT, right? So app metrics, infra metrics, attributes. So there are so many things which open telemetry collects from the application. Application in the sense that it also has the infrastructure. So it collects Kubernetes metrics, it collects your services metrics, it collects your pod metrics, it collects your node metrics, logging, if we talk about logging, application logs, right? And of course traces. I've been talking about traces, so end-to-end tracing, everything is collected. It processes in such a way and then exports to the backend agents, or as I said, it's just a telemetry collector. It doesn't have any storage to store logs or store matrices. It passes on to a backend tool. Okay, we'll see that in a bit in demo, that how open telemetry is deployed. I've already deployed, but I will show you the pods and the application pods, Kafka, Redis, which I've been talking about, and how these all the telemetry which has been processed are connected through a correlation ID, or the trace ID, you can say, and they are passed on to different backend systems and visualized on Jagger UI or Grafana. Grafana is a great tool. Grafana also provides its own implementations for logs called Loki, Tempo for tracing purposes, right? And Prometheus is for metrics. Prometheus is a good agent for metrics. right? So this is what the difference between the traditional way of collecting the logs, matrices, and traces, and then how OpenTelemetry has come up with this beautiful architecture, right? So in demonstration, I'll show you about different services. As you can see on the PPT, you have card surveys, ad surveys, accounting surveys. You can see Kafka here. Oh, sorry, here, yeah, here. You can see Kafka, that is queue manager or queue message-based application. You can see Cache, Valky. You can see these are UI applications, right? So each of it's a mixture of now this is a very good example which is OpenTelemetry has provided. It's a mixture of all the programming languages or the scripting languages along with your message-based application, your cache mechanism, uh, right? So this is I would say that this is the best example if you want to start with Stack Observability. This will give you the insights of each of your services, which has React.js, which has Java, which has Python, which has cache mechanism, which has message-based application, Kafka, right? So we'll see that matrices, list the metrics and show you all the matrices which have been captured from this application, right? So yeah, here you can see the service legend, right? We have every programming language or the scripting language covered in this example. Okay, so now the magic part. Let me go to Azure portal. Yeah, so we'll instrument an application for tracing logs and matrices. We'll see the tools which capture the backend tools which capture this tracing, logging, matrices, and how we visualize the metrics or the logs or the tracing on Grafana or Jagger UI, right? So let me go to. So in the interest of time, I deployed the application. Here you can see the pods, right? So we have account surveys, ad surveys, card surveys, and other services which are deployed. You can see Grafana is deployed here. You can see Jagger is deployed. Kafka, I talked about Kafka, which is also a popular tool for message-based application. Right now, Hotel Collector is on this cluster. Uh, Prometheus is on this cluster. I also deployed Loki and Tempo just to just to see that these are also options. But I couldn't connect this because I need some DNS to expose the service. I required DNS and all that expose and add it as a data source to Grafana. That we'll see in a bit. Right. So let me these are deployment. Just to get a holistic view, I deployed in a default namespace all the required tools. Here you can see this, right? Loki is deployed, Tempo is deployed. These are Grafana tools. All right. All right. So these the application and the tools are deployed on our cluster. They all are up and running. What I've done is I exposed couple of services as a load balancer type, so that I can run them. You see, a couple of them I have added as a load balancer type. Restore cluster IP, which is absolutely fine. This load balancer type will give me access to the IP and the port. Now, starting with Prometheus, I'll show you Prometheus. Okay, so before that, let me actually let me show you the open telemetry configuration. How the collectors, the processors, and the the other part is defined, uh, where the backend tools are where the traces should go, where the logs should go, and where your matrices should go. right? To process and then push it, right? So that configuration, let me quickly show you. If you see this configuration, this is a config map. This is a Kubernetes resource which you can relate it with your environment variables. It has capability of having this. It's a configuration file. It's which application the Kubernetes understands as setting the environment variables in the runtime. Right. So if you see here, we talked about exporters. Right. That if you here the endpoint OpenSearch, we have defined the tool. We have said this is the endpoint. So it start writing the logs to OpenSearch. Once this configuration is done, so these are the backend tools which I was talking about. OpenSearch is for logs. Jagger collector is for traces. Prometheus is for matrices. Okay, and let me scroll down and show you a pipeline. It works based on a pipeline. Here we go. Right, you better understand about this pipeline. This configuration, logs, exporters, OpenSearch. These are like if you worked on GitHub or GitLab, we define some stages and so forth. Right? So similarly, this configuration is a standard configuration for OpenTelemetry, and I have deployed it through Helm chart. If you guys don't know about Helm chart is an orchestration tool which orchestrates Kubernetes resources. I think Abhinav has talked about so many resources, service, your service, your role binding, and there are much more related to your Kubernetes. When you deploy application, so everything can be managed through a Helm chart. I'll show you GitHub project of OpenTelemetry, the demo, so that you better understand what is a Helm chart. And Helm is a popular orchestration tool, which has been quite popular, and it is easy to manage your Kubernetes resources. Okay, so this configuration is important because you're telling OpenTelemetry collector which are the backend system you need to push your signals, matrices, logs, or traces. Right, this is a standard one. If you have any other, bring your own tool, and you can configure your tool here, and it will start pushing accordingly. Okay, so this is a very important file. Right, now the OpenTelemetry collector is running. We have Prometheus, OpenTelemetry. Let's first. This is the application which has been deployed on my cluster. I'll quickly add one item to my cart and verify place order. Okay, my order is complete. This is one end-to-end transaction, and all of the services you see here, right? The add service, cart service, and now the flow goes through these services, and it's a complete request to response transaction, you can say. Once this is done, OpenTelemetry start collecting the traces, the logs, matrices as defined by the configuration to the backend tools. Now first we'll see the matrices. Prometheus is deployed here on the same cluster, on the same namespace, default namespace, and it's running on this IP and the port 9090. Right, so you see it's the same one. So using load balancer type IP, you can actually I have exposed it so that I can show you on browser how you can go for local host. If you deployed kind clusters, simple K3s in your local or using Docker desktop, you can go for local host as well. But I found this interesting. Rather than having on local host, there might be some issues with the demo. I exposed this the services as a load balancer type, and I'm able to access the tools on browser, the UI, right? So now all these matrices are scraped from the cluster which I was showing, where our application is deployed. All these services start sending the signals. Some of them are configured. Let me also show you that. And this is a source code for all these services. Just for example, let's go for that. So add services is a Java program service. If you go to build.gradle and search for open telemetry, you will see as one of their dependency, as I was talking about, right? So this is SDK type deployment. Okay, so this is not auto instrumentation. This is manual instrumentation. Excuse me. So what the service is doing is it's we are defining it as a dependency, and then it starts collecting the traces, matrices, and everything, and it will start pushing to open telemetry collector as well, right? So this is one service. Let me show you maybe Python. There's one more service which is of Python. This. Maybe. Let's go for React. Now. So go to package.json. Here also you'll see open telemetry dependencies, right? So you have to either auto instrumentation is through a runtime you can provide the agent, the open telemetry agent, or you add them as a dependency so that once you deploy it, your application immediately starts emitting those signals, right? Hope you guys understood, right, how this telemetry is emitted and then collected through open telemetry, and that's why I've shown the video, right? सब कुछ सीधा सीधा नहीं होता है. So there are too many things to understand, but I'm trying to make it simpler. Show the code as well, how dependencies are added. Taking example of Java, Python, I'll share this repository with you guys that you can go through, and let me show you the Helm chart as well. So this is the Helm chart. There are clear-cut instructions. You can follow the instructions for a Kubernetes cluster. Mind it, the memory usage is high, so you minimum need 4 gigabytes of a VM or a VM scale set if you're deploying into a AKS cluster or any other EKS or any other clusters, managed clusters, right? So mind it. So see that you have ample resources before deploying it. You can go through there's a beautiful documentation about it on their docs, the official docs. Okay, I'll share this documentation. I've taken this example because if you want to try it out, right, it will be easy for you to understand. And this is a great example for full stack observability. People are struggling with the observability. They're not able to track their application insights. What's happening with my specific component? As I've shown, right, there are so many components. Every component is being used on an enterprise level, or if you talk about banking sectors or pharmaceutical sectors, right? So observability overall covers everything. Okay, it covers infrastructure monitoring. It covers application monitoring, and it is critical. In today's date, it is critical to identify the patterns, to identify anomalies, right? And future now, AI is getting embedded into these tools to prompt. What does this alert means, right? How can you resolve these alerts, or how can you find anomalies before my service going down, right? So there's so much to add to it, and there's so much work to it. With AI coming in, there will be more development on this tools, observability tools, and yes, observability is important. Okay. I have shown you Prometheus, this one metrics part. I'll go to Jagger now. So yeah, this is Jagger UI. Again, if you see this, this is running on my cluster. I've exposed this. Yeah, here it is. Jagger. Right. Sorry. Okay, what happens is front end proxy is something like your queue proxy, which handles the network. Internally, this application is been written in a way that front end proxy will handle few of the components like Grafana, Jagger, and there are other components as well. Right. So what I have done is I have exposed front end proxy service as a load balancer type. So I'm able to access the application. If you see this, right, the application with the same IP 8080, and if I go to Jagger, I just say slash Jagger slash UI. Okay. So it will bring up the Jagger UI component. Right here we can track the traces. Let's go for add service and say find traces. It will show you the complete trace of this service, right? Let's see specific operation, maybe get ads by category. Right here. So this is really a good view. Now you can understand from the load generator service, it has passed to front end proxy. That's ingress. I was explaining, right, from front end proxies type of queue proxy, similar to queue proxy as an ingress. It port forwards to other components, Grafana and others as well. So from here it has gone to the router front end egress, right? So this type of insights helps the application developer to understand the performance of their system. So if there is an error, the error is also logged here in the traces. You can click here, see the error will be logged if there is an error. But you have a span. The span attributes tells you, okay, what happened with this service. It gives you the detailed insights of it, right? So you can see here, right, process command, and this uh, granular details so you can get from traces, right? So these are like default one. If you want to have let's say HTTP codes as a one of the span attribute, you can do that's possibility with OpenTelemetry. You can customize your spans. You can customize your logs, you can customize your traces. That's quite possible with OpenTelemetry, right? So this is about traces. This was about metrics, right? Uh, let's see the logs now. So all right. So what I've done is I've installed Loki as well, just to have more tools to understand, to give the audience feel about there are not only Jagger UI or your Prometheus or OpenSearch. These are not the only tools. Grafana has its fleet of products. Loki is for logs. Tempo is for traces. Jagger UI we already seen for traces, but you can also have that as one of the tracing components. It's upon you. It's all depends on the application requirement as well. Your stack, the tech stack. Now I was talking about. I've shown you a diagram, right, which has all the tech stack in it. So these using these tools, using Open Telemetry Collector, you can have this full stack observability. This gives you the complete insights of your application, not only application but your infrastructure. You can relate, have that at one place. For example, Grafana as a visualization tool, you can add each of the component. For example, so this is play.grafana. So every anyone can access this. It's just like a playground. They have provided dashboards. They have provided the matrices, insights of your Kubernetes cluster. You can explore this. Play.grafana.org. It's free for everyone. You just need to type in and start exploring. The traces which you have seen on Jagger UI, right? The same type of traces is possible with Tempo. Right? So service 0, service 1, this is just an example. I was talking about span attributes, right? So this also gives you leverage of, hotel gives you leverage of, customizing your traces, your logs, depending upon your application, your tech stack, and then collected by backend tools like Tempo or Loki, Prometheus, Jagger, OpenSearch. There's so many tools. Whichever fits best with your application, you can choose that, right? But OpenTelemetry makes it simplified. It's just a collector, but it has a capability of relating these traces, matrices, and logs, giving a holistic view of your application and infrastructure, right? All right, so this was about traces, logs, matrices, the application. All right, I wanted to show one thing. The last part, now coming to our visualization. Uh, okay, now we understand we have traces, we have metrics, we have logs. What to do with this data? There's so much amount of data coming in, right? We are collecting so much amount of data. We are scraping each of the pods, each of the services, everything we have. But how do you visualize it? How do you make it simple? How do you simplify your visualization of your data, right? So that's where Grafana comes in handy. It has capability of having multiple data sources. As you can see, I've listed it: Tempo, Loki, this Jagger, Prometheus. These are deployed on my cluster. I've added them as a data source. I've also added, because this is Azure. Azure has its own monitoring agent. Once we have connected that with data source, it's so powerful that each of the resources on Azure subscription can be accessed through Grafana. Once this data source is configured, you'll see that your subscription is loaded, and it has, see, this is now this is sitting on a cluster, AKS cluster, and I have added the subscription as a data source. It gives me the entire view. This Textonaut K, it's a subscription. And let me show you here. See, this is the subscription. So all the resources in this subscription can be accessed through Grafana now. Once we have it as a data source, you go to dashboards, create your own dashboards. There's a there's a portal where we have dashboards. Grafana dashboards. Let me quickly bring that up. All right. So these are like community contributors. So select your appropriate data source. You'll see all the templates, or you can say uploaded by community contributors with respect to the Istio or Node exporter. Now, all this can be queried through Grafana directly, but the community has already provided so many templates. You can reuse it, tweak it according to your application or whatever jobs you have defined, and then get it up and running. You can immediately visualize your data here like this, right? So latency of front end, error rates, right? There might be some problem with this logging. That's okay. But your Python services you can monitor. So there's so much scope to monitor your data with tools offered by Grafana as well, right? One more point to consider is to like as I said, like, open telemetry is only a collector to because we have logs, traces, matrices. There's huge amount of data. You need to have a storage as well attached to your other tools like Prometheus or your Loki, because to have your logs stored, Tempo for traces, right? Open telemetry doesn't have the capability of storing the data. It just processes and it pushes the data to the backend tools, right? Now Prometheus, your Loki, Tempo, other tools are such tools which has the implementation of storage. And just to give you a gist about, if you guys know about HDFS, Hadoop, right? So to have high availability of your data, right? To see the historical data, let's say for 12 hours, I want to monitor how is my application been, right? Then are there any patterns? Are there any CPU spikes or memory spikes? How do you understand? Maybe your application might be spiking at night, and by morning it's coming down, and testing team or sorry, if it is a production, production team doesn't have any clue. How do you trace back and see that what's the pattern, what's happening at night or what's happening at a particular time, and how can I get insights of your of it, right, of that timestamp, right? So that's where traces, matrices, logs, all these are helpful in understanding your infrastructure application insights. Open telemetry is one such great tool which processes all these, correlate all these signals, and it pushes to backend tools, which again we have visualization tools like Grafana, Jaguar, which are again are great tools to have this data at a single place in a single dashboard and to understand the patterns, right? Okay. So yeah, this was all about observability, the tools, why observability is important, right? This topic is vast, but if you start working on it, this will really help you. This is one of the important, or you can say critical topic, where you will encounter in your let it be if you do some POCs in your workplace, or you work on enterprise applications, you work anywhere in the IT companies. Observability is a must, and it is one of the checklist, or you can say compliance to onboard your application to production as well, right? So this is the importance of observability is was always there, but there was no there was no traction, there was less attention to it, but now the tools which are coming up are great. It simplifies how we observe our systems, right? So do start with your observability journey, and if you have any queries, questions, just reach out to me on LinkedIn, or just email. LinkedIn, I will share you the QR. But start your journey. This is the right time, and this is an observability era, right? And want to rest my talk by a statement that if you if you can't improve your system, or you can't improve anything if you don't have tools, or you don't have mechanism to observe it, right? So to improve your application or improve your app infrastructure, you definitely need observability. And this, as I said, this observability term you will always face whenever you're doing a deployment, or if you're in any role, SRE role, DevOps role, or you're an architect, or any role concerning IT, the roles which are emerging. Observability is everywhere, and everyone should know about observability. Now, full stack observability is something which was really important, which was difficult, and I thought this topic would be really great to share with, because I have done so much work on observability, and with the tools, fighting with the tools, understanding how they are implemented, and I try to get something today as a demo because this was difficult. I was requiring more memory, but I tried to deploy the application, try to deploy all the components, and make sure that audience at least see something on Grafana as a graph or as stats, and understand, relate the signals, the traces, metrics, and the logs. Right. Okay. Let me go back to the PPT.